Thanks, everybody. I really appreciate this opportunity to be a part of this forum. I am not a traditional biochar scientist, so I get to admit that from the very beginning. But I do want to kind of go into a really fun and unique story that we've been developing because it has a lot of applications. It's also becoming, for us, a more and more exciting opportunity that we've had in the field of agriculture. So I'll go ahead and do that. Just a little bit about me. So I lead our animal health program for IFF, that's International Flavors and Fragrances. If anybody is now scratching your head as to how IFF goes with biochar, yeah, it can be confusing, as certainly if you're thinking about a fragrance company being involved in this aspect. But we are actually, apart from all of our aspects in food and scent, we are a world leader in animal health and nutrition. And so that really, was what brought me into the industry, but also brought our company into working on this question and really helping to advance the applications of biochar here. I want to give a quick shout out and introduction to my research collaborator on all of the work that you're about ready to see. It's Dr. Kevin Kessler. He is one of the senior veterinarians for Tyson Foods here in North America. And I will tell you the story about how we got this going. And I will admit it was Dr. Kessler who brought us all into this world. So, but again, it's been really great and phenomenal. Real quick, I just want to use this as a basic framework. So again, we're transplants into the biochar arena. So it's always good to kind of talk about how that even happened and where that really launched us. It's also important to talk about where this really fits as far as an unmet need for sustainability in agriculture, sustainability in animal production, and where, again, all of this fits together. So it'll be good to spend some time there and, again, just give some updates on why this is important and why this is truly needed for our industry. A lot of the data and the program that I'm going to show is going to be around a long-term proof of concept program that we set out for. Dr. Kessler and I, are not tied to a major academic research group. We're field scientists, and that's really what we focus on. We focus on taking ideas and really translating them into true use conditions, and really allowing then your sort of translational programs of science that we know and we get excited about, but really helping them to get introduced into the industry and allow them to get their foothold. So again, we're going to talk about the proof of concept program that we have and why we're really excited about a lot of the findings that we have. It'll be good to also talk about, how it's launched us into, much more work into biochar and where that's going to go. So I'm excited to, again, present that to everybody. And then finally, we'll just finish up on again, just some next steps, but we'd love any comments or questions. Again, it would be great to hear some feedback from really the academic groups that I really admire in biochar, because it's your work and it's your science that really allowed us to get going fast on this program. So again, I want to make sure I can acknowledge and show my appreciation for the work that's been done before me. So again, we didn't come into biochar through a very natural route. We came into biochar because we wanted to grow better tomatoes. And I hope that doesn't catch anybody off guard. But that was really the topic of conversation that Dr. Kessler and I had together was, we both enjoyed gardening. We both enjoyed growing plants. We had been involved in tinkering and working on certainly for myself being a microbiologist, I'm always involved in the microbiome around plants and how that can be enhanced. But it was Dr. Kessler that really brought this idea of biochar. And again, how he had found on just his personal research, through papers and whatever he could find available to him about how, again, biochar was this truly wonderful matrix that allowed, again, several key issues that we, had been approaching in our own gardens, and how they might be improved with their use. So together, he and I just kind of kept the conversation alive. It was always an interesting topic and something that we could have fun playing around with. We moved that into, again, building our own systems, and certainly working on, again, sort of a do-it-yourself or work-at-home biochar system. So I would like to show a picture of my double retort. And I should show a picture of Dr. Kessler's. His looks a lot nicer than mine when we built them. But again, it was just so exciting for us to be going through these different steps in learning about biochar, and really picking up how much academic science there was around this. Again, really beautiful studies on the capabilities of what biochar could provide. And again, as our conversations continue to advance, it really brought us back into our own applications in the field of agriculture. So in agriculture, how we raise our animals is such a big topic, and where that can really go. So as we continue to again find ideas and opportunities for biochar, it just became too much of a good opportunity to translate a lot of that finding into, again, how we can help raise healthier animals and more robust situations. It's always good to highlight sustainability, because that's really where the bulk of our work has come from, and it's really been the inspiration for the push into using biochar in agriculture, especially within poultry production. I want to give a great shout out to the industry, because I don't think oftentimes the regular news channels and a lot of certain pieces of information really share more accurately about the work that agriculture is really putting out there to be a more sustainable practice, right? I do work in the area of large commercial farm groups. Tyson Foods being, certainly the biggest one here in North America. But it's also really good to, again, really try and re-educate people as to the wonderful sustainability programs that are here. I think one of the better statistics that I wish could be out there more is, when we raise poultry today, oftentimes it's up to a 75% reduction in the resources that we're utilizing. And that's been, again, a continuous improvement that we've had. And that numbers comes out of a study in 2020. So I'm hoping that trend has only increased. But we've really made strong, striving achievements in, again, improving our ability to farm and create sustainable protein sources for the world. And all of that on the back of, again, continuing to improve resources and find better ways of, again, optimizing our systems. I get to work a lot, not only in specific animal health, right? So I get to work with the animals and certainly work on the diseases that they're challenged with. But for me, it's always been hard to separate not only the diseases, but also often from their point sources that are involved in the situations that we raise our animals. So in this case, again, it's also good to understand that, a lot of where we raise our animals, so this is specific to poultry production, that up to 95% of poultry litter is used for fertilizer and land application. So as we raise our animals on bedding material and in an environment that will certainly be collecting a lot of their wastes and some of the spent feed, it's also good to know that, again, that's a very frequent and large scale process for us to be using as natural fertilizer for food production. High fertilizer costs, and that's certainly been, as of recently, have really spiked. And so, again, the ability to have non-chemical fertilizer and the access to non-chemical fertilizer, all the more important. And so, again, through animal production and certainly poultry production, we have a really great opportunity to seize that need and really continue to really contend to feed more back into sort of a circular economy of not only animals, but helping to secure the grains that we need for their growth. What I'm going to jump to is the last point is in all that I get to highlight around sustainability. There's always been a lot of focus on the resources that we're using in our system. So again, how much are we, adding as far as grain? How much are we adding as far as trucking and moving animals and materials between points? All of those have been really important, but one area that's always sort of shocked me is the fact that we've not had a major revolution in the area of litter management. And again, this is the bedding material. This is the material that we're raising our animals on. We've not had a major revolution in the opportunity to advance our science and technology here for many, many years. And so it's always been a really great and exciting area to help focus on and build up from, because again, we're finding so many advantageous opportunities to grow healthier animals and to grow in a more sustainable way. And now we're looking at an area that is really ripe for us to make a revolution and really make some better sustainability practices. Poultry litter, again, we're still talking about the environment and really the direct environment that these birds are in contact with. It's a double-edged sword. In one case, it's one of the most amazing things to use to grow really healthy animals. There's brilliant research that really showcases its ability to, again, support natural microbial control. Again, it can really aid itself into long-term use, which is nice because it allows for, again, us to make not only really great high-grade fertilizer from poultry, but it allows us to also not be a constant dumping source in order for it to move out into the environment. And again, if it's done right, it really has direct economic benefits into not only raising healthier animals, but also providing it and keeping the price point in the system that, again, helps to control prices. I know that's hard to talk about in the days like now, but again, in a lot of cases, doing your poultry environment right has, again, wonderful benefits, especially on the economics of raising animals. But again, I talked about it being a double-edged sword. So in this case, what we're looking at is when it's not well managed, it really starts to aggravate almost all of the points in animal production, right? It will start to lose time. It's also often, it is time intensive to do poultry and poultry environment correctly. So it is difficult for a lot of people to do. And unfortunately, again, if they start to cut corners, a lot of negative impacts can kind of enter the system. But it also can be, again, without the natural microbial control that good, healthy litter could achieve, it can also be a source for, chronic bacterial challenges. So in this case, right, it's going to be a lot of bacterial challenges to the birds. I specialize in non-antibiotic production systems. So again, we're raising birds in a really healthy and great manner. That also means that a lot of the tools that I can use to balance animal health are not there. So being able to control any type of disease from the environment only adds to my ability to, again, provide antibiotic-free and really great and healthy animals at the end. So I'm going to move into our study here. And again, this was a pilot project. So if you take two field scientists and ask them to do biochar research, this is what you get, right? You get two guys who want to get it out into a real life situation. We want to get it under as much commercial operation as we can. We want to see, again, without the strictures of strict controls and highly synthetic systems, if we use biochar in our current production practices, what are the benefits that we can really harvest and gain from having them in the system? So this was a system that we used. So I'll go through some of the notes. I expect this will be a lot of questions here at the end, so I'll be happy to take those. We first targeted a biochar application as a 7.5% by volume. So that's estimating, again, the environmental volume that they have between their current system of used litter as well as pine shavings, and then again supplementing that with 7.5% of biochar hand applied on top. So yes, that was quite quite a time in using our hands and shovels and getting biochar throughout the entire surface of the farms that we were working at. The source of biochar that we used was mostly pine. Again, the group that we were collaborating with at the time specialized in using storm debris, but also vegetative material that they could quickly get, and then going through a pyrolysis process to ultimately get biochar. The grind size was around 2 millimeters. That's not what we originally targeted. We wanted something much smaller, and I can talk about that later, but this was what we had available. So this is what we moved forward. In the design, we were going to look at a very simple time course of putting biochar in the environment but really allowing it to commingle with animals. So again, this was under commercial conditions. So there very much was live production animals being exposed to biochar and allowing them to be in the environment. But it also allows us to see all of the dynamics that you get when having a live animal system going on. So we ran it for a flock. So that's the life of placing young day of hatch chicks, all the way up to they reaching their target weights, at which point they're harvested and moved forward on into the processing plant. We then spent time taking that and sort of, again, helping to do the basics of management between having flocks there, between having flocks of birds in the system. So in this case, again, we still conformed to normal management practices, which in this case was tilling. So now once we had the biochar on top, we actively started to move it more into the column of litter in the system, but then repeated, again, the same sort of experimental design and maintaining our timing points and really moving through the points of allowing birds to, again, be in the system and looking at the effects that we can find. As a microbiologist, I'm going to look for, again, some of the microbiology points that I get really excited about. One of the dynamics of poultry in an enclosed system is that through a very natural process, you get an accumulation of bacteria in the system. And it's from the very simple action of birds eating and growing, but also pooping and depositing that fecal material into the environment. So it's fascinating, again, from that standpoint, because it's a very dynamic environment that's having constant inputs put into the system. And again, in under certain conditions, it can be managed, but under other conditions, it can become a runaway train. So we see a lot of this typical nature with bacteria. And I love to, I've been studying E. coli and Clostridium for years in these conditions. So they're really great sort of biomarkers for me because they should behave in a very typical fashion. And so in this case, what was interesting to us from the very beginning in that first trial, we started to see more immediate impacts on just overall E. coli density within the litter environment. And again, we typically see, E. coli can kind of come up and come down as conditions change and as, again, the bacterial populations of the system naturally regulate. So this is for the control system, this was a very natural a very natural trend. But again, what we got excited about was seeing, there's really this phenomenal control of E. coli. And E. coli, again, can be good in a lot of situations, but it also could be bad. It's, highly linked to a pathogenic form called avian pathogenic E. coli. And so again, by helping to overall control E. coli in the system, it really gave us confidence that, again, we were achieving some sort of modulatory effects by having biochar there. We see under the trial too. So again, we didn't reapply biochar. This is from a single point application and just really trying to study the long-term life and outcomes that we would get. In this case, we did see biochar start to spike up a little bit at the midpoint, but it did ultimately come back down at the point of harvest. So again, it was really interesting for us to see some of these control points and see why they were having an effect. Clostridium perfringens is another great bug for me to study because, again, it behaves in a lot of ways very consistently. So again, we can have a lot of history of knowing how it should be performing. Again, under the same trial one, we saw continued limiting effects of some of these hallmark bacteria. Clostridium itself, just like E. coli, can be a very benign form, but it also has very much links to a highly pathogenic form when it starts to pick up toxin genes. And so in this case, by helping to just control overall Clostridium density, it really allows us to start creating a barrier, not only to the environment, but a barrier to having pathogenic forms of bacteria that can cause health challenges. A lot of the trends that we, again, found from trial one, shifted a little bit. We continued to see that midpoint where, again, in the biochar samples, that number continued to increase versus control. But again, at consistently between not only E. coli, but now Clostridium, what we were able to find is that harvest period is where we were definitely starting to see separation now between having biochar in the system or keeping it under current commercial practices. This is another point that I like to celebrate because, being being in science and being especially in field science under the variabilities that we have to work under, it's always really nice to replicate data that you would anticipate. Going into all of our biochar research, I think one of the strongest pieces of information and that I've always believed in from the academic work has been the effect of biochar on sequestering metals from the environment. And so it was really brilliant, Christian, that you gave me the opportunity to go after Diego, because he really set up this work. So all of what Diego had been talking about and instructing from his research program was all of really the work that I got inspired on, in hoping that we can replace this effect in poultry production. So unfortunately, in animal production, there's a lot of inputs, especially metals, that we use to really build up the growth of our animals, right? So there are a lot of essential metals that are important for biochemical processes that are needed for animals to grow and to be healthy. But that does mean we're often putting a lot of that into the environment. And that they might be stagnant, to what Christian had offered earlier. They might have a leaching effect into the surrounding environment. If we're going to use them as fertilizer, now we have to maintain the dynamic of what's going to happen again when we're applying more of this out there in the environment. In this case, what we found very consistently across a panel of again, the metal ions that we were specifically looking for was, again, a consistent reduction, not only in trial 1, but also in trial 2. And again, the fascinating effect that we found here was, we are thinking we're actually identifying a time-dependent manner or a kinetic nature of allowing biochar in the system to commingle with these metal ions, and then allow that activity to then ultimately sequester them from the environment into the biochar. So again, this was really great. I know this is not an earth-shattering effect, and it was not meant to be, but for us, what was really great was under entirely different conditions that I think have been routinely studied for biochar effect. Under agricultural practices, especially here under poultry production, we were able to reproduce what I think is a really key piece of a really key component of biochar activity, which is, again, the fundamental relationship of acquiring and holding on to some of these metals in the system. So it was really exciting to see all of that. I'm going to break it down. Being in field research, a lot of what we have to do is also balance not only the technology, but also balance the safety to the system. Biochar in so many ways is incredibly safe. It had been well documented for its safety. I know in a lot of applications, it's also had its own use through the gastrointestinal route. So again, that was really great to see. In our applications to the environment, again, what we saw was, again, a very safe, and we've identified no negative impacts from having biochar with the animals. It has growing economic support for biochar use. So I get to being in industry, I do have to ask the unfortunate question of who's going to pay for this. It's great to have, again, amazing technology, but if it doesn't fit often within an economical system, it becomes something that may not be acquired and taken advantage of. So here we were, again, helping to grow an economic calculator for our use. From what we already talked about, it really appears to be working through previously published effects. That's really brilliant because, again, in our case, it's great to be reproducing, I think, all of the mechanistic science that have been built up to this point. So we were really happy with that. The microbial shifts are working, and we're still working on what is the true mechanism of action that might be related to it. What I didn't show is all of the total bacterial population analysis that was done along with, again, some of the more biomarker related data that we have on the individual bacterial species. The functionality of the microbial populations that we've been studying have indicated that we do see gross shifts in the general makeup of the population. It's hard to then deduce that back between whether it's a specific competition effect, it's an enhancement effect, or again, maybe it might be some other piece. But what we can also continue to see, again, similar to what Diego had presented, was by having certainly biochar in the system, there are certain relationships that are changing, especially among the bacterial populations that are present. Consistency is key, man. And that's what I just love to see, that And a lot of the proof of concept work, we were able to just see those effects work from flock to flock, and a lot of the work that we have ongoing, that this effect is very consistent. So it helps to really build our motivation and really build the application opportunity. Where we're going next, all of this proof of concept really built our motivation to continue to build this bigger and better. So we are working at repeating all of these findings at an entirely second poultry production system. So that is on board, and it's actually, we're finishing up with that. So that data will be available very soon, and we're looking forward to presenting that in the future. But again, this will be in going from Texas to Arkansas, even though regionally they're fairly close, it allows us to get a little bit more dynamic, but we are looking to push that into another region as well. We have partnered with the USDA at the Agricultural Research Station at Starkville, Mississippi. They are a partner group, so they've been running their own biochar programs. We've been trading protocols, but we've also been sharing data for an ability to really help bring, again, consistent outcomes that we can help highlight together. And then finally, we're also starting a more mechanistic research program with Auburn University, and that's specifically with Dr. John Lindhaas. So that'll be a lot more of where we can ask, again, the fundamental dynamics of biochar and density and all of these questions that we might want to answer. And again, what's driving some of the outward effects that we've already found. I have to talk about the economics of biochar and poultry production because, again, at the end of the day, this needs to be an important component of not only pushing the research forward, but also getting this research out to make it usable. We've already done a lot of calculations ourselves as to how this might reduce chemical needs. That's a big cost for a lot of poultry production. So again, it's great that this is going to be a source for us to help shape how, again, biochar can have a place. Reduce maintenance costs, but certainly improve poultry quality. So that's been one of the latest findings that we have is overall, when we look at some of our biochar programs now, the birds look better. And the best part is the meat quality that we're harvesting from those birds that are in a biochar system are of higher quality. And so again, that's been able to be quantified. And so that'll be part of our calculator that we have. Long-term use is still what we're needing to define. We've had single point biochar applications that have been run for almost an entire year without secondary reapplication. So we're still working on, again, the dynamics of single point versus multi-point biochar application. But again, we're hoping that, the longer that we can get on single point really allows us to build the economic case for its use. Improved litter fertilizer. So again, there's very basic calculators that we've been using for nitrogen content, as well as some of the other mineral content that really adds value. And of course, the ability to support faster farm prep. So again, if we can help create a healthy system, it allows for those systems to be replaced with chickens, it allows us to produce, again, more birds and really continue to help feed a growing population. So that really helps to finish it up. I'm going to end right here because, again, one last piece of information that I just wanted to leave with everybody to maybe stimulate some ideas and curiosity. One of the effects that we originally tried to study with biochar is it's linked to moisture. So often moisture is heavily accumulated during natural poultry production. The birds need to drink. There's often moisture in the air, and that could frequently all be contained and accumulated within the litter environment. That often is not good because, again, when we start to have excessive water, we start to have excessive microbial populations. We start to destroy a lot of the fundamental control mechanisms that are there. So I wanted to showcase this because this was the USDA work where they had found maybe not such a significant effect on biochar. Again, we were at 7.5%, so they're still much lower at what we were in achieving some of the microbial benefits that we found. But what they have been finding and very consistently finding is, again, the effect on helping to extract moisture out of the environment and ultimately get it more bound up within biochar. So we are showing increasing litter moisture from biochar in the system. But again, this is total moisture quantified as mass. So, right, so we take mass and we back calculate to the dry form. And so what we're finding is, again, we're actually extracting more of that water and making it less available to the microbial populations by keeping it maintained, again, in its bound form to biochar. So this was really exciting stuff. And again, it continues to build our interest and our passion for seeing biochar in agriculture continue to move forward. So with that, I'm happy to take questions. I will go back to the very beginning here. Please feel free to reach out to either myself or Dr. Kessler. Again, we truly appreciate this industry, and we truly appreciate the academics that have been behind us. We're able to go quickly into the commercial route because, again, the level of science that has been put forward allows us to take all of that work and really go with it. So again, for all of those who are in pure academic research around biochar, you have my heartfelt thanks for all of the work that you've all been doing. So thank you.
Thank you very much, Jordon. That was a very different presentation than we normally have, I would say. We don't have so much animal health in biochar research. So the floor is open for questions. So please shoot or otherwise write them into the chat. I had one question because I wanted to understand some of the volumes that you are using. So you said 7.5% of the liter volume were incorporated. So
yes,
on an area basis or on a just to give a relation, how much biochar you used in this system?
Yeah. So the average poultry house has about 1.2 metric tons of litter that's built up into the system. So we're using 7.5% by tonnage to be applied on top. So it was right around several hundred pounds that were applied of biochar to cover the surface. We did have uniformity of coverage. So again, what was fascinating from the first trial was birds are really on nothing but biochar and a little bit of used poultry litter that's naturally accumulated in the system. So, in that case, again, they're really on a field of biochar and seeing a lot of benefits to their growth. I didn't talk about that today because I wanted to keep it more towards, again, some of the direct physical and chemical benefits that we found. But what we found very consistently is that, again, the birds are healthier by having it in their environment. And that's really great for us. We love welfare. We love raising healthy birds. And so, again, biochar seems to be hopefully a really great component of doing that more in the future.
And you got two questions in the chat. So the first one from Nadav. Did you test the liter moisture in control versus biochar groups? I think that was shown.
Yeah, I highlighted that. I highlighted that in the USDA study. We also measured it for our proof of concept in the field study. The problem that we ran into is we ran this trial in Texas, which is very, very hot and very, very dry. So we didn't really get a lot of Texas almost never accumulates a lot of natural moisture in their environment. And so even though we did make those measurements, there was no real difference that we could find by having biochar in our proof of concept studies. USDA performed it in a separate state, which again is known for high humidity and known for more humidity accumulation in the environment. So for them to see differences, it makes a lot of sense. We will be moving into environments that have a lot more moisture. So it'll definitely be a key component of having it in the future for all of our commercial work.
And the follow-up was, did you check for ammonia release from litter? So did you check gas emissions?
Yeah. So that's been one of the contentious points, because I think biochar in a lot of cases has been shown to have a relationship in reducing ammonia. We think that's related to some acid component in the studies that we have to date. With unadulterated biochar, which is what I showed in our Texas study, we did not see any differences in ammonia. When we have acidified the system, we have found all of a sudden a very direct link with acidified biochar being very successful in reducing ammonia release. I've also been playing around with microbial populations to control ammonia. So that's been another piece that I didn't show here today, but we've also been using, again, exogenous bacterial populations supplied to biochar, and that's also had a very strong effect on reducing ammonia release during the production of animals. So again, I didn't show it just for our Texas data because again, the unadulterated biochar didn't have the effect, but when we can acidify the system, or we can add in a lot of the bacteria that we study, we've been finding a very consistent effect on the biochar being effective.
So you got a couple of questions now. So can you just quickly show the difference in the metals again?
Yes.
For another. So basically, we found lower metal percentage, or can you?
Yeah, and these are free available metals, right? So
Okay.
this isn't doing an acid leach, or this isn't doing any sort of adulteration again to the biochar. These are free available metals in the system that's separate from again anything else.
Okay, and probably while staying on the slide for another from Fountain Financial, are you seeing chickens eating the biochar?
Yeah, so that was probably one of the few negative impacts that we had from the study. Again, we used a 2 millimeter grind size for biochar. For what we wanted, that was huge. It was what we had, and it was what could be donated into the system. So you kind of have to go with what you get. Birds ate it. We found there were no gastrointestinal lesions. There were no negative effects from having any of the biochar, again, going through any of the postings that we completed, or any of the outward physical signs that we found in the birds. We did find biochar, though, in the last fecal material being deposited from the birds going to the plant. So it does appear that it has probably a slower gut transit time because of the grind size. We've seen other studies that have a smaller grind size that appears to go right through the birds, and have, again, no negative impacts that we could diagnose from any of the birds.
Next question was, what would be the planned final resting place of chicken litter laden biochar?
Could you say that one more time? I'm so sorry.
What's the final planned resting place of chicken litter laden biochar?
Yeah, so a lot of this will be moving out into farms. Again, we want to support that circular economy. We want to build out the biochar not only having an effect on the poultry that we're producing, but again, we want to be using that to enhance the farming systems that are around us. So all of this, the biochar to date has not gone out into commercial agriculture applications past our use. They've all been contained. They're all being naturally composted on site with poultry production. But we hope in the future that that'll be something that we can link within our studies and then start to include as well. So when that starts to be land applied, we'll hopefully be there as well to be looking at a lot of the soil mechanics and hopefully a lot of the benefits that can have as biochar moves out into that system.
You also got a question from Kelpie, or question or suggestion. Have you tried lactobacillus as an acidifier? Yes,
absolutely. That's part of our group, and that was our theory. We were using natural wood ash component, natural wood alcohol as our acidifying agent. Again, it works. It can definitely drop the pH, but it's adding a separate step in the birds. Well, it's adding a separate step in the process of applying biochar and then having to come back with the acidifying agent. What I'm excited about is what's really nice about using lactobacillus as a medium is they're already natural producers of organic acids into the system. They're also really healthy for the birds. So we can actually feed them to the animals and allow the animals to naturally deposit them into the environment. And it's a great vehicle without any extra steps of putting that bacteria in the system and then allowing the bacteria to naturally acidify the biochar. So that's a great idea. We've been using it. That's part of our current program at the moment.
You got a suggestion from Michael Dupont's work in Hawaii for swine, but you also got the last question now from Dalila regarding the dust when you use biochar, the dust production. How did you wet the biochar and how much? 20% or what do you say?
Well, yeah, and that again, we're not quite sure because we've applied biochar in other situations. We haven't had that significant dusting effect that we had from our first pilot program. But what we did is we applied by weight volume. I'll have to go back to the calculation, but we ended up applying about 25 gallons of water to the entire surface, to the entire production surface. So again, by weight, I'll have to go back and calculate that because I'll have to go from gallons. I'm sorry. Here in the United States, we really need to be on the metric system. It's terrible. So I apologize. I have to go from gallons to liters, liters to kilograms to give us the weight calculation. But it was 25. And then we tried to compensate because, again, we put a lot of moisture in the environment. And so we also used tunnel ventilation, which is just pulling air directly across the surface of the environment to help pull out any excess moisture that we could. So I think we ended up extracting probably around, I think the calculation is around 17 to 18 gallons of that water that was ultimately applied. So there was still a little bit of water that was naturally in the system that was just from our program to reduce the dust, but we did try and pull off as much as we could before the birds went into that environment.
So there's some place for optimization there, I guess.
Absolutely. Again, this is field science. We had a big dump truck with biochar, and they just kind of backed it up to the end of the barn and was like, all right, you guys do it. So we just figured it out as we were going. And again, hand applying was really tough. That might be another request that I have. If we can figure out a better way to spread it around a surface that doesn't require me and a shovel, that would be really great.
Yeah, so the field moved further or developed in the meantime before people did that a couple of years ago. So as the last question, so you worked with poultry. Do you see similar, or could you imagine similar effects to other farming systems, animal farming systems?
Yeah, absolutely. Again, we feed these animals a lot of these minerals because it's really great for their biological system. So they're essential and they really perform a lot, but it also means that we're putting them in a lot of situations that otherwise flow out into separate systems. So we are looking at using biochar for soil amendments for free range birds. That's been something I've been battling quite a bit as we've moved into free range poultry production. There's a whole separate set of microbial challenges that are related to sort of the environment paradigm coming back. So we are looking to also start to use biochar for soil amendment, but also potential soil protection for some of our free range birds. And then I've just started talking with a swine production group that's really interested in again, doing some pilot trials within their commercial operations. We might actually start, in that case, we're actually going to start from the remediation of their manure lagoons. So all of the waste from swine production is collected into a central reservoir. And so we're looking to actually start remediating at that point source and then working our way back up to remediating in their environment in the production barns. So to come, but from everything that we've learned and found, we don't anticipate there being a lot of differences. And again, I think the final outcomes that we have to date.
Great. So that's thank you very much. It's also a really good bridging to the next Green Carbon webinar, which might be interesting for you as well, because Martina Leon will talk about manure biochar, about revalorizing residues to fight against climate change. So probably something interesting. So thank you very much, Jordon, for your presentation.